shaping and directing. If we do not understand how complex technologies function, how systems of technologies interconnect, and how systems of systems interact, then we are powerless within them, and their potential is more easily captured by selfish elites and inhuman corporations. Precisely because these technologies interact with one another in unexpected and often strange ways, and because we are completely entangled with them, this understanding cannot be limited to the practicalities of how things work. It must be extended to how things came to be, and how they continue to function in the world in ways that are often invisible and interwoven. What is required is not understanding, but literacy. True literacy in systems consists of much more than simple understanding, and might be understood and practiced in multiple ways. It goes beyond a system's functional use to comprehend its context and consequences. It refuses to see the application of any one system as a cure-all, insisting upon the interrelationships of systems and the inherent limitations of any single solution. It is fluent not only in the language of a system, but in its meta-language, the language it uses to talk about itself and to interact with other systems, and is sensitive to the limitations and the potential uses and abuses of that meta-language. It is, crucially, capable of both performing and responding to critique. One of the arguments often made in response to weak public understanding of technology is a call to increase technological education. In its simplest formulation, to learn code. Such a call is made frequently by politicians, technologists, pundits, and business leaders, and it is often advanced in nakedly functional and pro-market terms. The information economy needs more programmers, and young people need jobs in the future. This is a good start, but learning to code is not enough. Just as learning to plumb a sink is not enough to understand the complex interactions between water tables, political geography, aging infrastructure, and social policy that define, shape, and produce actual life support systems in society. A simply functional understanding of systems is insufficient. One needs to be able to think about histories and consequences, too. Where did these systems come from? Who designed them, and what for? And which of these intentions still lurk within them today? The second danger of a purely functional understanding of technology is what I call computational thinking. Computational thinking is an extension of what others have called solutionism, the belief that any given problem can be solved by the application of computation. Whatever the practical or social problem we face, there is an app for it. But solutionism is insufficient, too. This is one of the things that our technology is trying to tell us. Beyond this error, computational thinking supposes, often at an unconscious level, that the world really is like the solutionists propose. It internalizes solutionism to the degree that it is impossible to think or articulate the world in terms that are not computable. Computational thinking is predominant in the world today, driving the worst trends in our societies and interactions, and must be opposed by a real systemic literacy. If philosophy is that fraction of human thought dealing with that which cannot be explained by the sciences, then systemic literacy is the thinking that deals with the world that is not computable, while acknowledging that it is irrevocably shaped and informed by computation. The weakness of learning to code alone might be argued in the opposite direction, too. You should be able to understand technological systems without having to learn to code at all, just as one should not need to be a plumber to take a shit, nor to live without fear that your plumbing system might be trying to kill you. The possibility that your plumbing system is indeed trying to kill you should not be discounted either. Complex computational systems provide much of the infrastructure of contemporary society, and if they are not safe for people to use, no amount of education in just how bad they are will save us in the long run. In this book, we are going to do some plumbing, but we must bear in mind the needs of the non-plumbers at every stage. The need to understand, and the need to live even when we don't always understand. We often struggle to conceive of and describe the scope and scale of new technologies, meaning that we have